Okay, so in this question, we are going to again take a look at tangential and normal components of the acceleration. So that's when we decompose the acceleration vector into two pieces. So generally speaking, the acceleration vector will be decomposed into tangential component, which is the component of acceleration on velocity. But in this case, we put this capital T, which is unit tangent. So that's like velocity, but make the entire unit vector, so there would be length of 1, and then plus the normal component multiplied by the normal vector, so that would be like the perpendicular vector to the tangential component. Okay, so we have this sort of decomposition. So let's go ahead and do that in this example. So first they want us to find the velocity. So which means that we're just going to take the derivative. So derivative of cosine is negative sine. So we're going to get negative. Now the 8 will come out to the front because of the chain rule. So 8 times 4, that will be 32. And then we got sine AT and then I. Now we repeat the same thing with the jth component. So 8 will come to the front. That will become a 24, right? And then will be cosine AT, because derivative of sine is cosine. Okay, now we're going to do the acceleration. That means one more derivative. So another 8 is going to come in the front. So over here, let's just substitute, figure out what is 32 times 8. So that's 256. Okay, so that would be negative 256 cosine ATI. And then 24 will be multiplied by 8. Let's see what that is. That's 192 sine ATJ. Now, there is one mistake I made, and that is because the derivative of cosine is negative sine. So that will also be negative. Okay, so that's that. Now we want to compute the velocity and acceleration at 0. So we're substituting 0. Now you should know that sine of 0 is 0. So there will be no ith component velocity. But a cosine of 0 is 1. So that will just become 24j. And then if we substitute 0 into the acceleration, we will get negative 256i. And the sine of 0 again is 0. So that's what we got there. Okay, next we're gonna find, so we got two vectors. So velocity vector at 0, that's gonna be 0, 24. And then acceleration vector at 0, that would be negative 256, 0. Okay, now what happens when we compute the dot product of these vectors? So this is actually going to be a much simpler example. When we find the dot product, you will see that that's 0, because 0 times anything is 0 plus 24 times 0. Again, this is 0. Okay, so the tangential component here is going to be 0 in this case. Okay, and then the normal component will be really equal to the magnitude of acceleration, because there is no tangential component. So here in this case, the normal component is the magnitude of the acceleration, because there is nothing to subtract from, because the tangential component is 0. So what is the magnitude of acceleration vector? Well, that's just going to be 256, right? Because magnitude of 256, I is a unit vector. To 256 you can pull out. So that really is just going to be 256 there. And that's it.